On this, so we've got a point to start next lesson. Right, so primitive function. Okay, so sometimes we may know the derivative, okay, and we need to find the original function. Okay, so this process is called anti-differentiation, or more formally as integration. Okay, the original function is what's called the primitive function. Example A. Right, I want you to differentiate x squared and hence write down primitive function. Right. So, on task, thank you. Differentiate. So we know how to differentiate x squared. So d dx, the differential, equals what?
2x.
Bring down the power, take one off the power.
Remember that stuff.
Okay, so the primitive function is what?
X squared.
So you're integrating that to get that. Anti-differentiation.
Oh, it's just the reverse.
I like this.
Oh, hence primitive. Ah.
Very cluey. Alright, b, x squared plus 3. And then hence write down the primitive function.
So we do the whole.
Okay, so when you differentiate this, bring down the power, 2x, and then of course we all remember when you differentiate a constant you get 0.
So the primitive is still.
And what's the primitive function?
2x. X squared.
Okay, but from the question, that really should be the primitive function, shouldn't it?
Yeah.
Yeah, but it's not.
But how do you find that if you only get the question?
It's got that smile.
Wow.
Getting there. Alright, next. C. Differentiate x cubed. Then write down the primitive function. So when we differentiate x cubed, we get what? 3x squared. So therefore, a primitive function of 3x squared is
Instead of 3, I keep saying 3xy.
we don't need to be talking about your x's in this room, don't we? Alright, D.
I thought we've been through this.
Alright, x cubed, take away 4. Then write down the primitive function from your differential.
It's still the same.
How many do you need?
Oh, it's for that 9 dB class. I've got it marked here. And do some photographs.
Which
Oh,
class? 9 dB.
Yeah.
A few of these.
Yeah, you need about 1
I really like
dB.
that.
Probably. There you
Yeah,
go.
that's enough. Yeah.
Okay.
Compasses.
Can I get you at the end of the lesson?
Oh, that'd be right. Yeah.
No worries. Alright. Very good, that's what I like to say. Alright, so what's the derivative of that? 3x squared, therefore integrate this. What's the primitive function?
But how do you know that it's...
It's got something to do with the squiggly. It's got something to do with the squiggly lines. I know it.
It's a constant.
Okay, so we can. Who said that? That was you, wasn't it?
Yeah, but
Who said the C word?
Oh,
Excellent. Alright, so we can see that 2x and 3x squared has many different primitive functions. So if I say plus 10, take away 8,
It has
take away a million, plus pi, whatever, okay, when we differentiate, we're going to get the same answer, aren't we? When we integrate, are we going to get the same answer? It depends.
oh,
Alright?
Squiggly lines.
he gets so excited.
So, the primitive of 2x is equal to x squared plus a constant of integration. Okay, don't forget Charlie. Alright, the primitive of
Never had a friend called Charlie.
3x squared. What's the primitive of 3x squared? From this, what we've been doing here. What's the primitive of that?
X to the power of 3 plus 2. C.
X to the power of 3 plus Charlie. Don't forget Charlie. Okay,
Charlie
so,
What, don't forget Charlie.
yeah, I could be even more annoying actually to use my first name.
Don't forget Chris. Chris, I'll never forget you.
Okay, so we have the following formula. So if Alright, so the formula, so if we have f dash of x is equal to x to the power of n. Okay, when we integrate, when we go the opposite direction of differentiation, okay, anyone observe the pattern in a formula sense?
No. You put the in back up there,
You put it back up there.
and you plus the C. Ooh, you're done.
Alright, so if I'm integrating x to the power of n, what would it look like?
N plus 1.
So x to the power of n plus 1.
Plus C. Oh wait,
And
What?
you have to get
divided
rid
by
N.
Divide by.
N. 1. X.
X.
7.
N.
Differentiate this. What is the result?
Divided by N
Is
plus
N X
1.
N minus 1.
n plus 1
Divided by
minus
N
1.
plus 1.
To differentiate it,
Yes, n plus 1, take away 1.
Divided by N plus 1.
go N.
Yeah.
Like,
Yeah.
Oh,
N
this is it.
to the power of N.
Okay, so f of x is equal to x to the power of n plus 1 all over n plus 1. Don't forget Chris.
You look so pleased with that joke.
Alright,
It's
proof.
like,
Uh-oh.
well, we haven't done one of these.
I don't want to... This involves...
Alright, proof 1.2.
If this involves differentiating by first principles, I'm going to be a happy chap.
Well, just because you said that, I could do that.
So, you just have really bad habit.
Alright, so if we assume x to the n plus 1 over n plus 1 plus c, if that's the original function and we need to differentiate, so going back to what you've learnt last term, alright, the f dash of x is equal to, so we need to bring that whole value down, the n plus 1 times x, we need to take 1 off the power by subtracting 1, and when we differentiate a constant number, it's 0. Okay, and we still have it all over the n plus 1 on the bottom, which is going to be a number, a real number. Okay, so I can cancel out the n plus 1 here with the n plus 1 here, because this is the product of two terms on the top, and I'm cancelling it with the entire denominator. What is 1 take away 1?
0.
So it'll be x to the power of n, which is that.
I don't understand how people just walk around.
Okay, so examples, find the primitive functions of the following. Alright, 2x, 3x squared, x cubed plus 2 and x to the power of 4 plus 4x cubed plus x. Alright, so before we leave, we'll get those four done. Sorry?
Didn't we already do 2x? Oh, that was
Exactly, so now let's apply the formula.
Wait, what do we write?
Oh wait, we do the whole...
You are finding the primitive, so you are integrating.
So like primitive function, is there a quick way to write primitive function is?
No, you do f dash of x.
Yeah.
Is there a symbol for it? Okay.
So, integrate
How do we write it?
that with respect to x, integrating that.
So do we write it f? Do we have to...
Okay, so what's the result? So when we integrate 2x, we get what?
Do we do f of 2x? No.
Okay, so we know this.
Yeah.
Alright, we want to go and get this. Okay, so it's going to be 2 because there's just a constant out the front. 2 to the power of x, we add 1, so the current power is 1. Alright, so we add 1. Oh, sorry, 1 plus 1. Okay, and then we put that new power on the bottom.
So 1 plus 1 again.
Yeah, okay. So add 1 to the power, put that new power on the bottom, multiply by any constant.
Plus...
Okay, so 2x squared on 2, which is x squared. Okay,
Whoa, that's
don't forget Chris.
when you find math skill.
Gnarly, bro.
Alright,
That was unreal.
the integral of 3x squared dx. Okay, so 3x, the constant out the front, add 1 to your power, 3, divide by your new power. Okay, so I'm reminding you the process because they won't always be straightforward what we worked out for the first 4 questions. So the integral of 3x squared, the primitive function is x cubed.
Did that one a lot
Don't
faster
forget Chris.
than
Yeah, so hit that now.
Alright, so the integral of that dx, so you're integrating the whole thing, so you can, just like when you differentiate, we can add or when you're adding or subtracting, we can break it up into separate parts. Alright, so x cubed plus 1, so add 1 to your power, divide by your new power. Okay, and then 2, now this is x to the power of 0 for a constant number. Alright, so it'll be 2x to the power of 1 over 1, so it's just 2x. Finished?
Plus C.
Plus the constant of integration. Okay, and that's why often when you integrate you're going to have fraction, because if you differentiate this, it will be 4x to the power of 3 over 4. 4 divided by 4 is 1, so you have x to the power of 3. Okay, that's why that works. Okay, so again, term by term. Okay, you add 1 to your power, divide by your new power. 4x, add 1 to this power, divide by that power. So x to the power of 1, add 1 to that power, divide by your new power, and don't forget the constant of integration. Okay, so the only thing we can simplify is this. So it'll be x to the power of 5 over 5 plus x to the power of 4 plus x squared over 2 plus our constant of integration.
That was gnarly.